Welcome, Ganesan. So glad to connect with you. And let me take a minute to introduce Ganesan. Ganesan is a very young, dynamic leader, recently leading a set of AI-related activities at IBM. But before that, almost 22 plus years of experience. So we are particularly interested in this segment because you are going to talk about the current initiatives at IBM, and we keep hearing about the latest news from IBM that everything is going to be AI driven in terms of products and services. So we want to see from your end how this data science is disrupted at the market client side or internal company side, what kind of use cases, and your presentation is going to be more on applications and the possibilities, opportunities out there for data science to tackle. So over to you, Ganeshan.
So excellent. So I think thank you for this opportunity. Hello, everybody. And data science has always been a very hot topic and will continue to be. And what I'll tell you is I will talk about my little bit of a career journey, and also what data science means to me. For the past 30 years, we have seen data science in different forms, and future also we will see data science in different avatars. But data science remains. This has been in existence since the time of those TQM days, where there was something called total quality management, and people used to talk about what is called fact-based decisions. And those fact-based decisions has taken different forms. And my career at least has been, I started with data science and I still remain with data science in its various shape and form. 30 years ago, we had this management information systems, and then business intelligence dashboards, and then event-based processing. So you have examples like in casinos. As you are losing a lot of money, you will get a free drink or free snack from the casino site, so that you keep going and keep losing money. This used to be an example almost 25 years ago of some of the TIBCO applications which were in existence at the time for these kind of event-based processing. Then came all those BI tools like Cognos, which is IBM's product, and you had MicroStrategy and whatnot, and business objects and so on. So then you got into a lot of analytics in different forms. We weren't calling them analytics, but we call them as analysis or business analysts or modelers. The applications like SAS, Jump, Minitab, all these applications, packaged applications were in existence. And R has been there for a very long time, the programming language R, but didn't have much libraries then. But you had all these expensive packaged applications, which is what we use for a lot of analysis. Tools like regression, logistic regression, ANOVA, general linear model, right, clustering, all of them, forecasting, all these techniques have been there for a very long time. And from around 2007-8, when actually the emerging technologies came up, and they talked about what is called SMAC stack, right? SMAC, SMAC stands for Social Mobile Analytics in Cloud, right? And that's when the term analytics came into existence. And from then on, it has been taking different versions. It was analytics for a while, then it became big data analytics, then it became data science, machine learning, deep learning, reinforcement learning, now artificial intelligence, transfer learning, GANs now. So there's a whole lot of different, techniques and methods and versions it is taking, but the spirit of data science still continues. It's all about getting data, analyzing data, learning through data, and developing some meaningful insights out of data. So therefore, this is a very apt topic. And by the way, Shino did a good introduction about me, and I lead the distribution sector, which is a combination of retail, consumer products, pharma, and travel, transportation, hospitality, these industries. It's a group of industries that I lead. Right now, my portfolio is not just analytics, but everything that IBM does, most of the services side. All my views in this is my own views, and this is not IBM views, but I will talk about some of the cutting edge work that IBM is doing as well. And there is IBM is at the forefront of data and AI and hybrid multi-cloud. You must be, as Dr. Shinu mentioned, there are lots of announcements coming out. You must have heard the latest announcement that we are becoming a hybrid multi-cloud and artificial intelligence focused player. And we are at the very forefront of it, and therefore there is a lot of stuff that I want to talk about as well. Okay, so with that we'll go to the next slide. So, I mean, this is known to you all, right? There's been a lot of media coverage. Harvard Business Review said data scientist is the sexiest job in the world sometime back. Data is new oil. And Andrew Ng, who is one of the major proponents of AI, along with Elon Musk and and Jeff Bezos and Mark Zuckerberg, they keep talking about AI becoming the new electricity. So the time electricity was introduced in early 1900s or late 1800s, they went through a lot of learning curve, in terms of how to put that to use. There were lots of accidents. There were lots of horrific stories on how they actually streamline the electricity supply as a major utility for the household, and how to use it with various devices, various gadgets that you have at home. I think AI is kind of in that stage. We have managed to analyze a lot of unstructured data in the form of speech, images, and text, but still there is lots and lots of data that is still hiding, right? That has to be brought out. What we call as the dark data. And analyzing these data, if you want to use the traditional tools of analytics, like the one that I talked about, which we used during the analytics days, they're not going to be just sufficient. You've got to have super sophisticated tools, because the number of rows are huge, the data volume is huge, and also the number of features and variables, these are huge. So the computational capacity is also building up. So you will not have much of human intervention in this analysis. There is a human intervention in terms of selecting the right technique, and then training the data and labeling them and so on. But then beyond that point, once the machine starts learning, the machine goes on and on. And as we get into the AI domain with deep learning, with deep neural networks, this is becoming more of a black box, right? Once you have the input and output, the machine maps the input to the output and then starts predicting. How it does, and our understanding of it remains challenged. Therefore, explainable AI is becoming the key focus these days. And there's a lot of stuff that IBM does in terms of explainable AI. You might want to search in the web. Well, now we are moving into the AI first world, and one of the top trends that the World Economic Forum came up with beginning this year, and there is a lot of open source tools and techniques available. OpenAI is the community that Elon Musk founded some time back, and there is lots of tools and methods and techniques, codes available on the net. The beauty of this is, in my view, the reason why it spread so fast is A, because of the compute power, which went up rapidly in the past 10 years, and B, because of the open source. Right? There's so many tools that are available, but then they may not be enterprise grade. To put that to enterprise use, you'll have to look at the tools that are available with IBM and others, the Watsons and others, which are enterprise grade, right? But for your analysis, for your training and learning, there is lots of open source tools and data and models are available. So the data volumes are exploding because of the devices, because of the social media, because of mobile. So it is in 2010, whatever data we had, and in 2020, what we have is 50 times of that. And proliferation of IoT devices. Our mobile phone has about some 15 sensors on an average, and all of them are generating data every second. And lots of videos are shot and uploaded in social media. So there is lots of images and videos. So there's a whole lot of analysis that's possible. There is a data explosion that's happening, and the compute power is keeping with this trend in terms of explosion data volume. The storage cost is going down and down, and the processing cost also per going down, per GB is going down. So there is tremendous improvement in terms of data storage and processing, which is in keeping with the explosion data volumes. And therefore, we get to deploy a lot of AI and analysis tools and draw insights out of it. So what are the trends, right? So there is going to be a lot of disruptions. If you see, if you take the computing area, so the transition that happened from when I was doing early in my career, statistics and analytics, was basically a lot of careful selection of various features and a lot of expert opinion going into building and developing model, to now where you just dump all the data and then choose the right tool. And even for choosing the right tool, there are platforms available which tells you which is the best model which fits the data very well. And then you are able to build a model and then deploy it. So because the compute power has become so intensive, and what's happening is all the traditional analytics that used to do with a lot of labor, manual work, is now getting totally automated. So because of the automation, there is a lot of time that is freed up for humankind to put their minds on various productive areas, and as a result, you have lots of innovation coming up. So even if you take the computation, you had CPU, then you had GPU for graphics and computer graphics and gaming and so on. Then you had TPUs, then field programmable gate arrays and FPGAs, and now we are talking about what ASICs, and we are getting into quantum. IBM is doing a lot of research, and IBM Q is available on the cloud. Even for trial basis, it's available, and you may want to search it out. So the quantum computing is available on cloud. You can submit problems; it will solve it for you. And so we are at the threshold of a revolution in computation, and there's a lot of automation that's happening across us. There is a lot of devices and linking out devices. And we're talking about an AI mesh, digital mesh, and so on. And convergence of multiple domains are coming into picture. So it's not just about computer science, not just about analytics and statistical tools and mathematical methods. It's also the domain and then the next practices. So all of them are coming together. The multiple domains are coming together to make the best solution and that's available. And I talked about the digital AI mesh, which is something that we are getting into, and Gartner is talking about these trends disrupting. So because of all of this, there is a lot of focus on intelligent automation. Many of the things are, chatbots have become a very common thing, right? Video recognition, facial recognition, right? Video analytics has become very, very common thing. Now it's available in your mobile phones, most of these features. And reasonably priced smartphone has all these features. Now, so whatever, because of all of this, humans will have to focus only on innovation, new ideas, how to put this into use. So our value, our time is going to get into all the thinking that we have to do in terms of making the world better every day. And that's happening. If you see, there is a lot of effort in terms of preserving our ecology, green initiatives, recycling. There's a lot of thinking. If you go into LinkedIn, you will see lots of videos, lots of ideas on plastic recycling, waste reduction, sustainable living, all of this. because there is automation, others going into automating a lot of mundane work, we have time to focus on all the advanced stuff, and that's how AI is disrupting and automation is disrupting our lives. So our belief, so what's going to happen as a result of this? So this is what I'm going to talk about, is all the advanced stuff. This is going to be about future. I know the data science is, we look at solving some business problems, we look at some traditional tools as well. But the future is going to be a lot of AI, and this is going to be a man and machine combination, right? This is going to be human plus machine, what we call as augmented intelligence. There was this argument whether it is human versus machine. It's no longer human versus machine. It's going to be human and machine together, making this world highly productive, improving our standards of living. And as a result of this, we are going to have lots of focus on ethics around AI, reducing the bias in AI models, and regulation around AI. If a bot, if there is a loss of life because of, let's say, a robot or something like that, who do you keep accountable for, right? Who's culpable there? Is it the robot? Is the person who made it, or is it the code, or is it a bug in the code? What is it? What is responsible for it? Is it an accident or a murder, right? So all these thoughts will come into picture, and as a result, I think there will be more regulation around how to put AI into work. And there is already a lot of, if you take the cyber crimes, it's fairly mature now. We have laws around it across the world, and now there is going to be laws around AI as well in future. So now let's come to the important point, right? So what is needed now? Now, we know that there is lots of tools and techniques that are available, but what is important is having the right data and having the right skills to analyze it. And this is where we have problem. We have a lot of people, when I interview people for job, or when some of my team members go ahead and forming the delivery organization for their clients, what they see is we come across a lot of people who claim as data scientists, but their knowledge is too shallow, right? And there is no in-depth understanding of the various techniques and the architectures and the tools that are involved. And you need to actually develop good experience with coding. There is no data science without coding going forward. Gone are the days when you actually played with those custom built applications, those SaaS and others, where you can solve. Enterprise Miner is GUI based. You can create a workflow and run it. But here it's going to be more of using coding. So you've got to develop some coding knowledge. Python is become a universal data science language. There is talk about more advanced languages that are coming up. Scala is right next to Python. R was there, but I don't know where it is now, but not many are talking about it. Python is kind of eaten the entire data science world. And there is new applications that are like Julia and others which are coming up, programming languages which are much faster is what I'm hearing. But Python right now rules. So you've got to develop in-depth knowledge, coding, working knowledge in Python, right? So all of you have to have that in your computers, should be developing, and that's absolutely necessary. Unless you have coding experience, you're nowhere close to being called a data scientist, right? But if you are only looking at some, as a business analyst and so on, so high level understanding is fine. But if you are calling yourself data scientist, you got to have real hands-on coding experience. And data engineering, right? So everybody started off big time with data science, nearly 7-8 years ago. And then they discovered that the data that's required for all the analysis is not in the right shape. So how do we get the data in order? How do we massage the data, harmonize the data, standardize, normalize data, and bring them together and make them clean and make them ready for analysis? How do we bring in the right information architecture to deliver AI? And that has become a big challenge. So data engineering became the most intriguing and most lucrative profession few years ago, right? I think that still is, because once you have the right data, once you have the right information architecture, IA, then artificial intelligence, AI, becomes much easier, right? So you need to have IA to have AI, and this is one of the perspectives from IBM. And once you have this AI model, productionizing it and then putting it to use is another important focus area. And that's where all the APIs and containerization and Kubernetes, all of this come into picture, right? This is not like just an equation that you plug in your Excel sheet and it'll run and it'll just give you some prediction, or you code it in your application. It's going to be now modular applications. You will have certain application, you will have the AI program running somewhere, and then you will have Python codes running, calling the TensorFlow codes or Keras codes or Cafe codes, and then they will bring it into the results into Python, and that will go into your Java code, right? So all of this, information applications architecture understanding is required. Knowledge of microservices, APIs is required for you to productionize. And then, of course, the security and scalability, all of them comes into picture. So these things like containerization is meant for scalability. Making these codes run for at large volumes and large call rates, and cater to a large user base. And then the security becomes absolutely important, because this AI codes, even if you do a minor tampering of the image, the data that you use for training, the result will be very different from what you expect. So therefore, productionizing and ensuring that these codes are running in a secure manner is very important. So this is a point I touched upon. I think the skills are absolutely important. Some time back, data science was generalized as a combination of the computer science, math, and domain, right? Now, what is computer science has become many subsets now. Computer science is not just about some coding in one programming language. You also need to know about and things like microservices architecture, APIs, and containerization. So all of this is becoming computer science, right? And most of big data is also programming. And of course, Python for machine learning is there. Plus, you need to know the business context. You can't put this into use for business unless we have good understanding of what are the drivers for business. What are the senior leaders in business after? In terms, is it cost? Is it revenue? Is it productivity? Is it utilization, or is it supply chain efficiency? Is it inventory? You need to start thinking in terms of business KPIs, and what business KPIs need to be influenced, and what are the metrics that influence it, and how do you model those metrics? What we call as Y in our statistics language, the key output variables, and what input variables influence them. So that understanding is what I call the domain knowledge, and that's absolutely necessary. And then only you will be able to put this into effective. So the business context, domain knowledge is very important, and equally important is computer science and the various mathematical techniques, the statistical techniques. It started with statistics. If you have to do some regression, you need to understand the least squares and things like that. And in statistics, you need to have some basics of basic knowledge in statistics. And now it's also moving into areas like linear algebra and vector mathematics, all of that. So some mathematical background is also important. So I kind of put some thoughts around what is a typical life of a data scientist or a AI engineer, or a data engineer or data scientist combination looks like. It kind of revolves around this, understanding the business context and the use case, what we call as what's the use case that we go after, and what sort of data we need to bring, and understanding, ensuring that the data is right, doesn't have much bias, and doesn't have sparsity issues. It's well spread out across, and it covers the entire span of your prediction range. So all that basic analysis you do to ensure that the data is the right data, then prepare data, and then extract features and build a model and deploy them. So this is kind of the entire life cycle. I'm sure when you get into your course, you will have deep dive into each one of them. And as I think, so analytics, like I said, right, many of the things haven't changed. As you learn in your course, you will see that a lot of techniques have been in existence. Regression, some 50 years old, I think, right? And ANOVA and general linear models, these are all very old statistical techniques. And so is the case with most of the, the linear algebra and vector algebra kind of models, mathematical techniques that we bring into machine learning and AI. And even this neural network is 50 years old. MLPs have been in existence in 50s. People tried to attempted to create AI in 50s and 60s, right? And so this is a very old thinking. It's just getting packaged. All of these are coming out of the universities and get straight away getting into the end consumer, right? Going all the way up to the end consumer, right? And the businesses are leading this transformation. Okay, then I will continue. So, like I said, the journey it starts with the business domain expertise. First, where do you want to apply? Is it supply chain, finance, HR, right? Or your core manufacturing? There you need knowledge of IoT and various other things. And then going into the deep learning IT side of things, which is basically programming in either of Python or any other Scala or any programming language. Then understanding the mathematics and the more the stats behind it, and then also learning certain techniques like NLPs and others. And this is actually the technical part of it. So there is a business domain part, there's a technical part, and then there is these softer things like communication skills. How do you explain the model? How do you explain your work to somebody? Right? How do you derive meaning out of the conclusions that is coming from your analysis? So all of this and how are you able to explain this becomes very, very important. Oftentimes, I find great experts know their stuff. They can build something, but when you ask them to talk about it, they're not able to present. I think this part is also equally important because we employers like us don't want to lose somebody just because they're not able to explain the great work they've been doing and the knowledge that they have. So this is something that you need to focus as well. So that's where your project and your case studies and all that will be helpful. I hope you have those in your curriculum. And how do you actually interpret? How do you make sense the numbers and how do you interpret those? I think that thinking also becomes an important. So in machine learning, you teach a machine how to learn, right? And from there we need to get into how do you teach humans in terms of what work you've done and how you explain it. So that's how your whole journey of AI looks like. So with that, I will jump into some examples that we have. So in IBM, we are at the forefront of AI. A lot of cutting edge work that is happening in the agricultural side. There's things like precision farming and digital agriculture, and how do you integrate IoT platforms, and some of the things I'm going to talk about in the next couple of slides might sound a lot kind of a ski kind of a thing, but it is happening, and you will this kind of work is currently underway. It's even happening in India, right? So that's the kind of work that's happening in IBM. I'm very proud of that, and this should be able to inspire you further. And how do you use AI for a lot of recommendation engines on what's the right jewelry that customers should be selecting and how does it look on that person? It's a combination of augmented reality and artificial intelligence and recommendation engines working in tandem, right? And I'm going to talk about some more examples there. And we are also we're working with developing the power AI systems, and IBM is also into a cloud and hardware and hybrid cloud business. So we have come up with deep learning as a service, which is a cloud offering for which gives massive processing power to various enterprises, and that's what is actually driving the adoption of AI. So So this is about digital farming, the first example I want to talk about. In fact, we are doing this for Niti Aayog. We did this for Karnataka, the farmers in Karnataka, in terms of their price prediction of their potatoes and corns and other crop that they are growing. So there are two ways to to do this precision agriculture or digital agriculture. You can use IoT devices. You can actually use drones to monitor your crops. You can put sensors for moisture and temperature and so on. And you can have flow meters that measures how much of water is going into this crop. And you have rain monitoring, all of that. That's a very expensive proposition. We have billions of hectares in India of arable land, and if you have to hook sensors onto each one of them, every plot is going to be a very expensive thing. So that's where IBM has come up with this fantastic cutting edge solution, which uses combination of the weather channel and the massive database that we have about the entire world, right? So the weather channel is owned by IBM. It's an IBM company, and the weather channel, the weather company, it's called the weather company, and that's the one providing weather information to all the channels in the world, right? They buy at different levels of granularity. Some buy data at a very fine level, in a short distance, a kilometer by kilometer, and some actually buy data at a city level or a county level or a regional level. Depending upon how fine the data is, the accuracy changes. But the weather company is a provider of data to most of the weather channels, and we have information about the rain and humidity and precipitation and temperature and so on. So this is one side of the data. So there are three legs in this. This is one leg. The other leg is we have a tie-up with the European Commission and NASA in terms of spectral photography of anything on the surface of the earth, any place. So this is basically IR cameras which can pass through the cloud barriers, and it can actually send a signal and detect the image. And based on the image, the image processing is done to detect what crop is there. So if you, for your farmland, if you give me permission, and if you want me to scan your plot, I can scan and tell you what crop is growing in your plant. And we have massive database on the geology, soil type, gradients, and so on. When you put all these three different data pieces together, it's one massive big data, right? Running to several hundreds of petabytes. And when you analyze this data, we are able to predict the moisture level at up to 1 meter depth, right? So we will be able to say that in your plot, this is the moisture level, taking into account the rains and the weather conditions and the spectral photography and all of that, gradient and all of that, we will be able to predict. So we have moisture level, we have spectral image. Based on the image of the crop, we can also detect if there is a pest attack that is happening, if there is a disease that's plaguing the crop. So all this information can be used for monitoring crop health and also predicting yield from the crop. See, for example, if you are growing, let's say, grapes in your farm, we will be able to predict what will be the yield that you will expect. And based on that, based on market condition, we can even predict the pricing that you need to go for. So this is very helpful for farmers, and a lot of Indian customers are using it. So we did an experiment with Niti Aayog. It's very successful, and we are doing, with there is a very large fertilizer company called Yara, and they are a big customer for IBM for this. We have also been working with a whole lot of other companies, and for confidentiality reason, I'm not sharing their names, but this is one massive application of big data, analytics, machine learning, and everything put together. Okay, the next example I'm going to talk about is in fashion. Okay, so 20% of in the fast fashion industry, in a fast fashion industry, you have 12 seasons. You don't have 3 or 4 seasons. You have every month you come up, there is a trend. There are people going into fashion shows, taking photographs, and whatever is current, trending at this time, these fast fashion companies produce those clothes, and they go for sale. But what happens is 20% of them don't get sold at full price. I mean, many of them don't get sold at full price, but 20% just remains unsold. What happens to the inventory? It goes as landfill. Now, these clothing industry requires a whole lot of, it's a massive consumer of water. You would have heard that to make a pair of jeans, it takes thousands of liters of water. Now, after wasting a lot of resources, after making these clothes, and if this ends up as a landfill, this is a sheer waste, and this is a massive burden on the environment. So we took up this challenge. So we came up with a fashion AI solution, which, based on the type of the cloth, based on the type of texture, color, fit, finish, neck type, and various other features, it can predict what will be the sell-through rate at a store level. So this is, some of the fashion industries majors are using the solution. And the merchandiser who is working for a retail company, if any of you are from retail, you would appreciate this, that there is a merchandiser who is planning, okay, this product, should I put it in the shelves? How much goes into each store? And all those decisions are made. So those decisions influence the sell-through rate, and we are working on reducing this unsold inventory, and also the markdowns and clearance sales and so on. So it's profitable for the fashion retailer. It's good for the environment, and it also avoids a lot of waste. So this is an AI-based solution. It tags the clothing characteristics, the product features, to the product sell-through rates using lots of AI algorithms. So some more examples, like you have in the AI, you have what's called GANs, generative adversarial neural networks. Basically, these are two neural networks competing with each other. One is generating ideas, and the other one is comparing that with a realistic solution and then scoring it. And there is a competition going on between them, more like a gaming. And the result of it is you come up with a design which is or a product configuration which is innovative, which is something that you've not thought about, but it is unique. Right? It's totally new, and it is also feasible. It is acceptable to the consumers. So that's what we have done. Jewelry is a very, very complex area. This has been done in terms of product features and specs and all that stuff. We have worked with a lot of fragrance companies, flavors companies, right? And we have come up with unique flavors, unique fragrances because of this. But jewelry has, many, many features. And therefore, doing this for jewelry is not easy. But we managed to do, this is something that IBM has done. And finally, supply chain is a major area for AI application. The demand forecasting back in my analytics days, even before analytics in early 2000s, when we used to do a lot of forecasting, we used time series techniques, Holt-Winters methods, and ARIMA and so on. But now the demand forecasting has gone the deep learning way. So now we use LSTM models and others, recurrent neural networks, and we are able to come up with accurate prediction of the forecast. The accuracy level has gone up because of the deep learning techniques getting into it. So there is also an impact of it on inventory positioning and how much stock you should keep. This is sort of an optimization that we are able to run. Reinforcement learning techniques are used for coming up with the right inventory policy across the supply chain. And similarly, the case with order optimization and product return and so on. So supply chain is another major area. There are lots of variables in it, right? Distribution points, inventory position, inventory levels, inventory on the shelf, inventory in the back areas. So all of these decisions are now driven by AI algorithms and a lot of deep learning techniques. So these are some of the examples that I just wanted to talk about. IBM has lots of solutions in this space. Even I've been with IBM for the past 1+ year, and prior that, like Shinu mentioned, I've been in various other roles, leading analytics businesses. But I'm like a kid in a candy shop now. So there is a whole lot that we can explore, and there's a lot to learn. There is no end to learning in this space. So stay inspired, stay hungry, and stay curious. So with that, I will end my talk, and I will probably take a few questions if you have. Otherwise, I will log off.
Yeah.
Over to you.
That's wonderful, Ganeshan. As you rightly said, uh, I want to know what is your skill. I mean, because you are leading large geographic area clients and all that. If you have to put yourself in their shoes, and what kind of skill is that you possess? I mean, is it that business understanding as major area, or machine learning as major area?
Right. So I think that's a very good question. So, as I am currently in the current role, the skill that's expected is different. So at my level, then it's all about business understanding, use cases, context, and knowledge of what is available in AI also helps. Once you know that these things are possible with AI, this is the level of accuracy you can expect in a chatbot, or in a text mining, or in any text extraction, or what do you call as that NLP based, you take an image and then you convert into text, so all of that, there is certain accuracy limitations. Your understanding of what is possible, what is not possible also helps. But certainly the key thing is about how do you understand the challenges of the business, and domain is more than the techniques and coding and all that stuff. But if you go one level below it, the domain will be slightly less. It will not be that strategic. It will be a lot of operational understanding of how the domain works. For example, the supply chain expert needs to know all the different practices within supply chain and KPIs and metrics. Then a deeper understanding of the solutions and mathematical models and techniques, and then a little bit of coding. But if you go one level down, the strategic and business understanding and the techniques will go down. It will be going more into the coding and developing an algorithm and so on. So so at my level, yes, it is more of business understanding, the context, and how can we leverage the power of AI to solve business problems. I think it stops at that level. But having said that, I've grown through the ranks, and I started off with doing this analysis myself, building models 20 years ago. But that also helps to some extent.
Any specific questions on Ganeshan? Anyone?
So,
yes, Kapil.
Yeah. Well, from the examples that you have just given, so what we see is that the process of data acquiring is either through, say, IoT, you said earlier, or you replace it with some other technology, or further in the next example, it was like, what is the production data, and the third example, what basically is the forecasting. Based on that, you acquire the data, get it in form of big data, then process it, and then apply your algorithm and apply AI and ML on it. So is this the basic this thing? How we go about it?
Yeah, I think there is. So that's that cycle I talked about.
Yes.
The data science life cycle. So
Yes.
so basically, you need to first start with what business problem you are trying to solve. If it is supply chain problem, you'll have to look at what's the current data on, what's the inventory across, what's the kind of transportation you have between the 2 points, and what's the consumption rate, what's the fulfillment rate, what's the demand, and what's the supply factors, and what's the sales rate and sell-through rate and things like that. So you need to have a good understanding of how this entire supply chain area works. Then you have to move into data collection, because there are many parameters. So far supply chain optimization has been done ignoring weather data. But now when we put weather data, since we have weather data with us, we are able to get far more insights out of that analysis. In fact, weather influences supply chain parameters, the sales and all that in a big way. If you talk to the beverage companies, they'll tell you that in how the summers are very different from the winters, and that's the case with most of the industries. So weather data, even demographic data, the impact of, let's say, lockdown on these beverages, right, on food consumption and the retailing and shop sales. So all of this has a bearing. So you will have internal data, you will have external data. You need to bring the data together and put them into some structure, and that's the data engineering piece. Then you move into your analysis and insights and models and prediction and so on.
Right. So basically, now when we come to the output of the whole process, what do we expect? What kind of accuracy do we expect? The output, and how do we ensure that it is the best accuracy that we get? So do we apply A/B testing or hypothesis or some kind of this thing?
No, so accuracy is limited by the tools that we use. I was just talking about OCR. Typically OCR applications have about 50-60% accuracy, right? And the ones that are commercially available. But if you go into certain, deep learning techniques, certain deep neural networks, you are able to get, better accuracy than that. So accuracy is a function of, a couple of things. One is the modeling techniques you use. Now you have plethora of techniques that's available. The amount of data that you have, right? The amount of scoring, the examples that we use, the labeled data that you use, the volume of it, and the spread of data that you use. So all of that has a bearing on, on accuracy. So the way you actually measure accuracy, there is a methodology. I'm sure it will be covered in your course. It will become a big lecture if I talk about you partition the data into training, validation, testing. With the test data, you are able to establish the accuracy, right? So it's kind of like A/B testing, but it's slightly different. So you will learn that, I think, in your course.
Okay, I'm good now. So with the example, the agriculture example, what you spoke about, right? Now you did speak about different aspects of things. For example, the moisture of the ground and the crop. How long does it take the crop to generate, and what is the type of crops you can, and the soil and all those things, right? Now this data calls for different things. Now, for example, there is data, then there is analysis, and then what do you do with that analysis? Those kind of things, right? Do you prepare individual tools or something like that for this, or is that something that you customize Watson to do with an existing code already?
Yeah. So it's a good question. So Watson is the basic engine, right, on which all of this is running. So IBM has centralized everything on Watson, and but the way we deliver to the consumer is very, very interesting. It's just an app in their phone, right? So you're a consumer. You put in the geofencing of your farm, and then you sign up for this. You can actually track, this is going to be your yield, and these are the threats that you have. These are the diseases the crop is undergoing. This is how you actually apply the pesticides, and this is how you apply manure or fertilizers and all that stuff. So you get recommendations to the farmers. In fact, we have done this for a large Indian public sector bank. And so it's an interesting use case. It's for the financial services industry, but they lend to the farmers, but they need to ensure that the farmer should be able to pay back. So what they do is they offer this as a service to their customers, and then you sign up for this, and you get all the insights on your mobile phone, and you apply those, and you will get better yield. And when you get better yield, you make good money, and when you make good money, you repay the loan. So this is kind of becoming an ecosystem. But to answer your question, yes, you can deliver this in multiple views, multiple ways. And the best way to deliver, in our view, is through digital channels using handheld devices. And your mobile phone is the best handheld device everybody has.
Thanks very much.
Yes, Python is a great data engineering tool, right?
Yes.
So it's not just for building models. It's got many, many libraries for data engineering. So you can actually develop websites using Python, right? Python is a programming language, right? It came before, it's the first open source application. It came just before C, I think. It came in 70s, I believe. So people used it for developing websites in the past, for web applications, for building applications. So therefore, there's immense number of things, and Python is a great visualization tool too. So you have a lot of libraries available for data visualization too. So and it's becoming absolutely universal. Yes.
Ganesan, hi. I just have a question. Hello.
Hi. Yeah. Go ahead.
Yeah, my question is more generic actually. In data science, when we use these terminologies ML and AI also, right? So what is it like? Is it like how is the conjunction between them? Like,
So
is it
machine
like
learning is the techniques, is a group of techniques, and artificial intelligence is actually the domain, right? Artificial intelligence is basically enabling teaching machines to learn from the data, right? And machine learning is a group of techniques
okay?
that's the first lot which came in AI. So a lot of ML techniques like SVM and KNNs and k-means clustering. So all these techniques were applied a whole lot by these internet companies like Netflixes and Airbnbs and Ubers and others, right? So these were all the first lot of machine learning tools. So this is called machine learning, which is basically, and there are three kinds there, supervised, unsupervised, and the mix and all that. So um, then came deep learning, right? So deep learning is all deep neural networks. It's a special branch of machine learning, I would say, right? So neural network is a machine learning tool, but deep neural networks, there is a specific way you actually train those models, is something called back propagation, and there's a whole lot of specialized, things that you do to develop a deep neural network, and that branched out into a very big domain by itself. Then you have reinforcement learning. So all of these are techniques within the domain of AI. So the way you domain AI is through the way you deliver AI is through these techniques, either machine learning, deep learning, NLP, reinforcement learning. So a combination of all of this.
Okay, how does it fit in into the data science as such? Like,
Well, like I said, everything is data science, right? So when we started, 30 years ago, right, 20 years ago, when I was developing logistic regression models, I was doing data science, but nobody called me a data scientist then. So, and in future, whatever you're going to do using your deep neural network is also data science, right? This is all about analyzing data to draw meaningful insights or come up with some prediction or prescription.